Gentlemen, we have reached the final engineering technical session of the 15th International Research Conference of General Sir John Kothalawa Defence University. It is my pleasure to welcome all participants to the civil engineering session based on the engineering theme of the International Research Conference, Achieving Sustainability Through Research and Innovation. The session will be chaired by Professor Upaka Rathnayake, while the rapporteur will be Ms. Latika Hittige. I would like to take a moment of your time to introduce Professor Upaka Rathnayake. Professor Upaka Rathnayake graduated from University of Peradeniya in 2006 and went on to receive the University Scholarship for Best Performance in Engineering. As an undergraduate, he received the EOE Pereira Prize for Structures in the years 2003 and 2004 consecutively, and was also awarded the Thurai Raja Prize for Geotechnics in 2006. Then in the year 2007, Professor Rathnayake was awarded the Monbuka Gakushu, Japanese government scholarship, with the nomination of Hokkaido University to pursue master's studies at Hokkaido University, Japan. Upon completion of his master's, Professor Rathnayake was awarded with the Strathclyde PhD studentship and the Overseas Research Students Award Scheme scholarship to pursue his doctoral research at University of Strathclyde at Glasgow, United Kingdom. Professor Rathnayake is a researcher in water resources engineering and is currently working as a senior lecturer in the Department of Civil Engineering at Sri Lanka Institute of Information Technology. He has worked in several countries in the capacity of both academician and researcher, including Japan, United Kingdom, New Zealand, Fiji Islands, Australia, and Sri Lanka. Professor Rathnayake is an eminent academician working as an editor in many reputed journals. He is the editor of Applied Computational Intelligence and Soft Computing, lead editor of Advances in Meteorology, and guest editor of Advances in Civil Engineering. Further, Professor Rathnayake has been awarded the Outstanding Reviewer Award, Journal of Hydrology, published by Elsevier, Amsterdam, Netherlands, in the years 2016 and 2018. He is also a member of the International Association of Hydrological Sciences, member of National Science Foundation Sri Lanka, life member of Sri Lanka Association for Advancement of Science, member of Institution of Engineers Sri Lanka, member of Water Engineers New Zealand, and member of Engineering New Zealand. Last but not least, the chair for today is someone who has immensely contributed towards the development of the educational and engineering sectors in Sri Lanka. Thanking the presenters for their endowment in making this session a success, I would like to cordially invite the chairperson for today, Professor Upaka Rathnayake, to commence the civil engineering session. Over to you, sir.
Well, thank you very much. I'm kind of flattered with the introduction. I hope that was kind of an extensive bio for me. It's an honor to be the chairperson for the technical session 3, parallel session 1 here. Today we have 3 presentations from the environmental engineering and water resource management sector. So without taking much time, I would like to invite the first presenter to go ahead with the presentation. And this is, the title of the first presentation would be Ceramic Tile Waste as Fine Aggregate for Marine Concrete Modules in Sri Lanka. So this was co-authored by SU Liyanage, IGN Anuradha, SN Gangabadarachchi, RY Galagedara, RU Halwathura, and PBTR Kumar. The presenter will be Mr. Samudika Liyanage. Beg your pardon if I do mistakes in any names, but I would try my very best to go ahead with the correct terms. Mr. Samuddika is a professional product designer currently working as the head of design and development at NCH Biotech Private Limited. He completed his bachelor's in a degree in design and at University of Halwathura and currently completing his master's degree in civil engineering. Further, Mr. Samuddika is keen in the research areas of sustainability, resource engineering, and material engineering. So the podium is for you, Liyanage.
Good evening, everyone. My topic is reuse ceramic glaze tile waste for the development marine concrete modular. Global production of the ceramic tiles is more than 12 billion square meter. The manufacturing ceramic tile generates ceramic waste powder during the final polishing product. The production ratio in very high in the industry. In the ceramic tile industry, we look the Asia in the 68%, and the manufacturing, the consumption, and same the Asia. The lot of manufacturing and consumption that our country. That's a global rate. Growth rate is the same. A lot of the Asian countries are the same. A lot of the high rate in the tile manufacturing. That's the current situation of the ceramic tile waste in Sri Lanka. The fact of Roselle, Lanka tile, and Mac tile, and lot of countries use the different methods to reuse the tile waste. We can use they can use the concrete and the rubber road construction and bricks. But in Sri Lanka, 1 or 3% of the reuse that waste. All are the dumping. That's why I select that area in doing my research. There's a production process. That's a waste are the implement. Mainly production process. We can divide the before killing and after killing. We can use 100% waste before killing process, but after killing we can use that waste. The all are dumping. The manufacturing process in the tile factory. That's a process that mainly generate the tile waste in squaring and polishing department. I try to find in what are the ingredient that waste. I can find a lot of silica ingredient, and that waste can mix well with the concrete. Some research, and I identify the advantage of the tile waste, the economic advantage, environment and technical advantage. After that research part, I heard some country use the concrete waste using some coral plantation method. That's why I try to that waste use marine ecosystem. I build a marine ecosystem. I select the coral and other things, and I try to understanding what are the threats and threats in the human and natural ways for the coral environment. That's why we need the coral. The coral is the natural barrier of the against coastal area and providing a lot of nutrition. Likewise, that's a Sri Lankan coral reef placement. And that the issue of coral destruction. Coral reef are dying around the world, damaging human activities. As example, coral mining and pollution and overfishing. That's the current situation in the Sri Lankan coastal area. That's why it's happened. Healthy coral reef, and they are died. You can see this image, how to impact with the environment. And that is the current solution in the coastal area. A lot of countries are using sea wall, water break, and metal structures, but that's technical. Some are not eco-friendly. Some that like a sea wall, it helped be a reason for the decreased biodiversity, and purchasing some equipment are very high cost. That's some different research in some countries in the world. In the Sri Lankan engagement, they identify the gap of the marine conservation. All projects are concerned about the one part of the environment, and material limited for the we are using, and technology. The technology and methods are different, and it's not very user friendly and maintain a cost. I tried to doing some pilot project in Polhena coral reef, because that area 80% of coral are dying. That's context. I will make a small concrete block and deploy the sea. That's the difference of the after 9 months. I try to, in my solution, create ecosystem for use in waste material. The design solution. That's a design solution we need to iconic fish breeding and coral growing module, and it's a very sustain for the environment. Need to sustain. The challenge is that design and this is all solution need to suitable for the marine condition and marine species. In my research, I will divide the three category: design development, material development, sample deploy. In the design development, I inspiration the current coral patterns and that the natural patterns, sketches, form I develop, and models, 3D modeling. That's why my final design. I try to make a dual module system, because a lot of project that type of project, they are concerned about one part. They make a concrete model and go to the sea and deploy. I will try to create ecosystem. That is the concept for the using the Polhen area. I use 2 modules for the develop that area marine biodiversity. It's like a building blocks. We can blend with the natural environment for these models. That's I call coral hab. The structure, that's a detailing. Then we can use that using that module. It's a different structure for the environment, because the environment is not a fix. They changing every time. That's a detailing. That's other module. Ring condo. That's how to fix it. Material development. In that part, I use the only fine aggregate for the in the fine aggregate in the concrete mix. I do some test, some resistance concrete. Next, I try to some fine integrate. What are the integrate the waste? Some place. And sample deploy. That is after 6 months, and that footage taken by after 3 days in deploy that module, we can usually fix that structure. And we can collect some fragile live coral parts, and we can fix with some epoxy cement. This other module, so only one. I previously said that footage taken by after 3 days. The module deployed. Okay, thank you.
I kind of forget to introduce the Latika's role here. She's not in the well. It was a wonderful presentation, and that gives you some engineering concepts and going beyond the engineering concepts and application of them to the product development. So the forum is open for any questions, clarifications from Mr. Liyanage.
Sorry, I can't hear.
Testing.
So we use the tile waste to make the concrete material, cement material. So how about the strength? Normally we use metals to make a concrete, and with this will the strength reduce or increase?
I can see my presentation again.
So when you use lime inside this one, I believe I get the question, like, for example, we have reinforcement in the natural concrete. So what would be the impact of your inputs to the concrete, and what happens to the strength? For example, compressive strength of the concrete.
Some mix they are high the normal strength. I use the 1 to 4 mix ratio, and I replace on the sand. For this research, I only use in the mix for the sand replacement. One sample in the strength is high, the more than the normal strength. I think.
Okay, thank you, Dr. Nadika. I think.
So you are going to deploy these things at the Polhena beach, right? So at the moment, yeah. So my first question is like, because it says you have tested for heavy metals and it's not detected.
I will.
Yeah, right. So what about the other pollutants, other parameters? For example, nutrients and all these, that total Kjeldahl nitrogen components, and how you reckon, so those also may be below the detected level or something. How do you say?
I've done this research with MIPA, and they helped me doing the deploy and other things. First I test the XRD. I need to find that material can't have lead and other chemicals.
Yeah, that's right. So that's only about the heavy metals, right?
Yeah, in that time I will search only that part.
So only you have tested only for heavy metals, right?
Yeah.
So then what about, let's say, because you are keeping this ultimately in the sea, and that's seawater, right?
Yeah.
So that all calcium, magnesium and all these hardness ions are there, and high alkalinity. So with the years, not a very short impact, thinking of maybe in 50, 60 years, So that is like, don't you think that when it is in the surrounding, that at least we noted that pollution and we like hide it, hide the pollution which can be.
First stage in that research, we try to definitely the future, what are the other parameters.
So what, I didn't get it.
In that stage, we are only using the only heavy metal, but future we try to definitely
other parameters.
Yeah, definitely.
So even literature, that from the literature at least you have noted some marine ecology pollution might be that, I mean not in short after the, like in a shorter period, but if we think of long term, cannot be expected like marine ecology pollution and all these things, because fish and all, you know, then they can eat sometimes and, you know, kind of.
You mean
with the wear and tear of these things with the
waste, tile waste?
Yeah.
I'm not clear.
So I mean, let's say you are keeping this in the sea.
Yeah.
Right? So with the years later, with the time, so there are fish, flora and fauna, right, around these things. So aren't they get impacted from this thing?
Yeah. Because I firstly in that research the very first stage, and definitely we tried we collaborate with the MIPA and other students. Definitely we check the other parameters and Madam say.
Okay. Thank you.
Yeah. Thank you very much for the nice presentation. And I'm not a civil engineer, but let me ask clarification as a layman point of view. Now in nature, you know, most structures are sort of having porous now. Even you can see in corals we have microchannels inside. So now your structure seems to be more robust and solid, sort of no, like the porousness is, as per my knowledge, it is missing there. So can you kindly explain that one? And the second clarification is, in the first structure we see more rounded shapes, whereas in the second design you have sharp edges, which we will not find like maybe the block type one. So can you kindly clarify that? Thank you.
We have two design. In one of the like a hexagon. That time we use the hexagon, we can connect the lot of module.
Yeah, but my question is that in hexagon you find a lot of sharp edges, whereas you don't find it in that the polar type one. You have rounded shapes, but whereas the hexagon one you have sharp edges, lot of sharp edges.
Yeah, that we use that hexagon type is a lot of the fish breeding, and sometimes we can use the water break and other like a plate. That's how you use the shapes. We engage the coral reef directly. That's how you use that shape, but it's it's not the direct contact with the human. That I not see the evidence that's a harm for the fish or anything in currently. That's I use shapes for that reason.
How about the porousness of
We tried to the porous because the coral needs a very hard structure to the attach the body, and we try to in the research. Not the research is not finished. We are continuing. We try to different methods for the reduce the the porosities and other things.
Well, I think this drives to a fruitful discussion, but we'll move to the next presentation, and thank you very much, Mr. Liyanage.
Thank you.
Hopefully, once we complete all these presentations, we can have another round of discussion points that to drive some conclusions from the research work which has been carried out. So let me take you to the next presentation. Now, this is one of the beauties of COVID-19. Nowadays, we are kind of a hybrid mode for most of the things. So our next presenter would be joining from online platforms. So Now, it is going to be identification of pathways for phosphorus-based product recovery from sewage sludge using multi-criteria decision analysis for Sri Lankan context. Okay, that's a longer one. Presented by, co-authored by K.A. Lakshan and MAS Preethika, and the presenter would be Mr. K.A. Lakshan. He's an undergraduate of University of Peradeniya, specializing in chemical and process engineering. So his research interests are along the lines of process engineering and resource engineering and focusing on waste management. Lakshan, I hope you are there.
Yes, sir. Can you hear me?
Yeah, you can go on. Ms. Latika will be notifying you at 8 minutes and then wrap up the session by 10 minutes. So then we'll have a quick session for questions. Okay, over to you.
Okay, sir. Thank you very much. And I think you can see my screen.
Yeah, go ahead.
Okay. So good afternoon to all of the esteemed guests who have gathered at the conference. My name is K.A. Lakshan, and the title of my presentation is Identification of Pathways for Phosphorus-based Product Recovery from Sewage Sludge using Multicriteria Decision Analysis for Sri Lankan Context. The research carried out by myself and Dr. Srimali Preethika from Department of Chemical and Process Engineering of University of Peradeniya. And as an introduction, let's see why phosphorus is important. Phosphorus plays a major role when it comes to agriculture and has to be externally supplied since it has a high impact towards the growth of crops. And currently, phosphorus fertilizers are manufactured using excavated rock phosphate, and scientific calculations and show that these rock phosphate reservoirs will deplete within this century. So this prediction has led the scientific community to search for alternative methods to produce phosphorus and related products. And in this scenario, our top point, wastewater, comes into the stage. Municipal wastewater is contaminated with various pollutants such as food waste, urine, fecal matter, blood, and much more named and unnamed organic and inorganic waste. After the digestion at the wastewater treatment, the phosphorus which can be found in those waste sources are retained in the sewage sludge. So this sewage sludge has attracted the eye of the researchers as a promising source of alternative source to produce phosphorus. And there has been a number of researches and studies to find novel methods to recover phosphorus from sewage sludge above mentioned. From a long list, we have selected 5 methods which we see suitable for Sri Lanka. This shortlisting was carried out by considering parameters such as the ease of supply of additives, power requirement of the process, machinery requirement, and also points as manpower requirement. And the shortlist is supercritical water gasification of sewage sludge, strew-white precipitation, thermochemical treatment of sewage sludge, wet chemical treatment of sewage sludge, electrodialysis. And let's move on to each of these methods and discuss briefly about them. In the supercritical water gasification of sewage sludge, devoted sewage sludge is dried and then it is cooled. After cooling, it is dissolved in deionized water, and then a gasification is carried out in a gasification chamber. After gasification, the residue is leached using sulfuric acid to produce phosphoric acid. That's the end product. If we talk about phosphoric acid, it's not directly applied as a fertilizer, but it has its own uses in different applications. In the process of strew-white precipitation, devoted sewage sludge is leached using sulfuric acid, and then it is filtered. After filtration, heavy metal removal is carried out using bentonite, and then it is mixed with magnesium chloride and ammonium hydroxide to precipitate strew-white, which is also known as magnesium ammonium phosphate. And when compared to phosphoric acid, strew-white is highly suitable for agricultural applications and can be directly applied to fields as a fertilizer. In thermochemical treatment of sewage sludge, devoted sewage sludge is incinerated and then it is ground and sieved. After sieving, it is mixed with magnesium chloride, and the secondary incineration is done to remove heavy metals as heavy metal chlorides. After the second incineration, the majority of the residue is magnesium phosphate, and it can be used after grinding and sealing. Considering other two products we have discussed, magnesium phosphate also not widely used directly as a fertilizer, but it also has its own applications in other fields. In the wet chemical treatment process, dewatered sewage sludge is incinerated and then it is leached using sulfuric acid. After leaching, the filtration is treated with bentonite to remove heavy metal compounds, and then it is hydroxide and magnesium chloride are introduced, just as in the struvite precipitation process, to precipitate struvite. In the in the electrodialysis of sewage sludge, the dewatered sewage sludge is incinerated and the ash is mixed with sulfuric acid, and the medium is electrodialyzed to produce phosphoric acid. When considering these 5 methods, each of them has their own advantages and disadvantages. It is not fair to select the most suitable method by just overlooking. Therefore, we decided to go with a mathematical technique called multicriteria decision analysis to compare each method by considering their strengths and weaknesses. There is a number of multicriteria decision analysis techniques, tools, and algorithms widely used in scientific studies. Some of them are Chromity, analytical hierarchy process, Electri, Dexi, and Topsys. For our study, we selected Topsys, and since it has been widely used in waste-related calculations and research work. Topsys, which is the shorter form for technique of order of preference by similarity to ideal solution, can be can be used to select the best method by evaluating multiple criteria using a weighing scheme. The algorithm of Topsys consists of 4 steps, which are normalization of data and weight addition, calculation of Euclidean distances, calculation of performance scores, and ranking of performance scores. To carry out the Topsys analysis, we had to select criteria and define them. For this task, we referred Sustainable Development Goals, which have been published by the United Nations targeting year 2030. And after carefully going through Sustainable Development Goals, we came up with 11 unique criteria. Those criteria are phosphorus yield from the process, cost to treat 1 gram of sewage sludge, estimated income per 1 gram of sewage sludge, energy consumption of the process, carbon footprint of the process, approximate time to process 1 batch, fertilizer suitability of the end product, heavy metal content of the end product, chance of mechanical failure of the process, noise impact of the process, and technical complexity of the process. Then we moved on to create the method criteria matrix. Considering the selected criteria, we carried out the literature survey to collect data for each of the methods we have selected. And then after collecting data, we came up with the method criteria matrix that you see on the screen. Then the most important part came, the weighing part. For the weighing part, we considered 4 different scenarios. First one is equal weights, where we gave every criteria the similar weight. Then the 3 different scenarios were taken, which are environment conservation, profitability, and fertilizer applicability. In these 3 scenarios, a base weight of 1 was given to each criteria, and according to the importance of the criteria towards the selected considered scenario, the weight was increased or decreased in a range of 0 to 2. After defining all the weights, we entered all our collected data into the Topsys algorithm, and the Topsys algorithm carried out the analysis and returned with the result you see on the screen. According to the results, the precipitation, struvite precipitation process can be considered as the most suitable method to produce phosphorus from sewage sludge, since it has excelled all other methods in each scenario except profitability. And on the other hand, supercritical water gasification is the least suitable method for Sri Lanka, since it is a highly energy intensive procedure, and also it does not include the heavy metal treatment steps. So those 2 are the major findings, and the there are some minor findings as well. And continuing to the analysis results part, the study was done remotely as a desk study. So there are a few more factors to consider to increase the accuracy of the result. The requirement of increase of supply of additives, dust and effluent emission, and the requirement of manpower are some of the parameters that haven't been included in the study. So inclusion of those parameters seems to be important. And when considering the final products like magnesium phosphate and phosphoric acid are not directly used as fertilizers, but they have their own important applications in other fields such as fertilizer manufacturing. So in future studies, these extensions has to be done regarding the results of the study. So after considering those factors, we can increase the accuracy of our final result. So this is the list of research articles, websites, and other things I have referred throughout the study to collect data. And finally, I would like to thank Multicriteria for the support I was given, and also the Department of Chemical and Process Engineering. And also I would like to show my gratitude towards the organizing committee of International Research Conference for the opportunity I have been given. And that marks the end of the presentation. And thank you very much.
Okay, thank you, Lakshan. It was a wonderful presentation. Let us have a couple of questions probably to Lakshan or clarifications.
Yeah, sure.
Okay, until we have a couple of questions, Lakshan, now what are your next stages of this one? I know this is carried out as an undergraduate research project. So what is the next step?
So next step is this was defined as a desk research. So when it comes to actual on-hands experiments, it was not actually financially feasible. So we have to carry out a very extensive literature survey. So after in future, this has to be extended to considering many more criteria. So like we have even though 11 was featured in the research, we had come up with about 20-25 different criteria. So the problem was we did not have enough data. So things has to be considered, since I find this research very suitable for the time we are discussing, since there is a fertilizer crisis in our country as well.
Okay. Any clarifications from yeah, we have one question. I hope you can hear. Yeah.
Hello, Lakshan.
Yeah.
What is the purpose of adding phosphorus? I mean, in chemically, are there molecular polarization to agglomerate the particles together for the sludge?
No, actually, we don't add phosphorus to the sludge. In wastewater treatment, there is a digestion part, and in the as I mentioned earlier, there are some sources that generate bring phosphorus into the wastewater, like fecal matter and organic waste, since there is phosphorus in those things, and this is like a cycle. Phosphorus is not generated, but what I do is we try to extract the phosphorus retained inside the sludge. Am I clear?
Yes.
Any quick questions? Now this Lakshan, this would be an interesting research, because even though we have so-called guidelines for fertilizers and so on in Sri Lanka, but hardly practices by the farmers. You put in you don't amount for the fertilizer input to the fields and so on. At the end of the day, they washed and they combine with the runoff. Finally comes to different sources, same as probably sewage as well. So interesting point. Hopefully we can have a couple of discussion points at the end of the 3 presentations. So be with us, please. Okay, thank you very much.
Yes, sure, sir. Thank you very much.
Okay, that takes us to the last presentation of the technical session, and now this is going to be another interesting research work. It is about optimization of coagulation and flocculation processes in Kandana water treatment plant, co-authored by PG in Nilmalgoda and MB Samarakoon. So the presenter for this research work is Ms. Ganushika Nilmalgoda. She's an undergraduate of in the Department of Civil Engineering, Faculty of Engineering at General Sir John Kotalawala Defence University, and I think she's working on environmental pollution and water treatment to her research work. So Ganushika, the floor is for you. Yeah.
Good afternoon, everybody. I'm Ganushika Nilmalgoda. I'm civil engineering undergraduate of General Sir John Kotalawala Defence University. Today I'm here to present my research on optimization of coagulation and flocculation process in Kandana water treatment plant. First of all, I would like to give a brief introduction about my research. In Sri Lanka, we use river water for drinking purpose. It contains turbidity and many suspended particles. In water treatment plants, the main aim of conducting coagulation and flocculation process are to separate suspended solid portions and to remove turbidity from water. In water treatment plants, the main aim of conducting coagulation and flocculation process for coagulation and for the coagulation and flocculation process, we use different types of coagulants. Coagulants are the chemical compounds which contain a positive charge on their surface. As this figure, when coagulants are added to water, positive charged coagulants and negative charged colloidal particles are clinked together and form floc particles. Then these floc particles become heavier than water and it settles down to the bottom. So in many water treatment plants, alum sulfate or alum is used because of the low cost and the availability. But there are some problems associated with alum. They are produce large amount of aluminium hydroxide sludge, and higher residual aluminium concentration cause some health effects. And if there is a high aluminium content in drinking water, aluminium ions may accumulate in water distribution networks. And alum is highly acidic and induces a drop in pH value of water. It creates some indirect expenses for pH, for pre and post pH adjustments, for sludge treatment and sludge disposal. To minimize these above problems, I tested the efficiency of iron-based coagulants, ferric chloride and ferric sulfate. For my research study, I selected Kandana water treatment plant, which is located at Horan area, and the main raw water source is Kaluganga, and total capacity is 120,000 cubic meters per day. And Kandana water treatment plant provides drinkable water and water for food preparation, personal hygiene and sanitation, and agriculture. So this is the picture of Kandana water treatment plant. The main aim of my study is to find the best alternative coagulant that can optimize the coagulation and flocculation process in Kandana water treatment plant. There are three main objectives in the study. The first one is to study the available alternative coagulants and their advantages and disadvantages through the literature review, and select suitable chemicals for the study. The second one is to compare the removal efficiency of turbidity and color at different turbidity levels for the selected alternatives and alum sulfate using laboratory data. The third one is to select the best alternative coagulant for the coagulation and flocculation process. This is the overall methodology of the study. When we talk about the methodology, the first thing is the raw water collection and characterization. First of all, we collect 32 liters of raw water samples from the distribution chamber of which is receiving water from the Kaluganga, and all sample containers was washed and purged several times with the same raw water sample. The preparation of stock solution. Stock solution was prepared by dissolving 1 gram of coagulant in 100 milliliters of distilled water, and it produced 1% strength solution. This figure shows the stock solutions of alum, ferric chloride and ferric sulfate. After preparing the stock solutions, we conduct coagulation jar test experiments for these 4 coagulant types: alum, ferric chloride, ferric sulfate, and for alum with ferric chloride solutions. So this is the jar test procedure I have followed. For the raw water samples and after the jar test experiments, I measure these water quality parameters: turbidity by turbidity meter, pH by pH meter, color by visual comparison method, and alkalinity by titration method. Flux size was visually observed using slow mixing stage. Now I'm going to show the results obtained from the laboratory data. Turbidity removal efficiency. This 2 graphs shows the coagulant dose versus turbidity removal efficiency, and the second graph shows the dose versus residual turbidity at initial turbidity levels 22.6 NTU. And in here, ferric chloride shows the maximum turbidity removal efficiency, and it is 93.1%. And this table shows the optimum dosage of coagulants at 3 different turbidity levels. Removal efficiency of color. These 3 graphs shows the color removal efficiencies at initial turbidity levels 22.6, 135 and 270 NTU. The effect of pH. The pH was dropped after adding all the three types of coagulants, and the effect of alum with ferric chloride solution on pH reduction is minimum. For the flock sizes was observed during the soil mixing stage, and the flock sizes observed were changed from pinpoint flocks to fluffy flocks, and those flock size classification was given by the Kandana treatment plant. And these three figures shows the flock formation during the chart test experiment. As the conclusion, we can see ferric chloride and alum with ferric chloride solution shows the best turbidity removal efficiency, and alum with ferric chloride solution shows the best color removal efficiency. And ferric sulfate requires a higher dosage during optimum condition compared to ferric chloride and aluminium sulfate. The effect of ferric with alum with ferric chloride on pH reduction is minimum compared to other coagulants, and iron-based coagulants produced larger flock sizes than alum, and they shows faster settling time. As finally, we can conclude that iron-based coagulants perform well in high turbidity than alum. These are the list of some references. And I would like to express my heartfelt gratitude to Dr. N.V. Samarakoon and to the officers of National Water Supply and Drainage Board. Thank you.
Okay, thank you very much. Any quick questions for to discuss, because we are moving to a common discussion. You can have one or two quick questions or clarifications to Ganeshika. If not, we'll move to the discussion because okay, Ganeshika, thank you. We will have a common discussion now. We had three wonderful presentations today. That's the harvest of the research work that they have carried, and we believe that harvest would enhance the country's situation towards a betterment or better place. So we had the first presentation from Mr. Liyanage, who talked about the ceramic waste as an alternative material for fine aggregates to produce concrete blocks or concrete structures, again as an alternative to the coral reefs and so on. Now, very interesting research, and there were some discussion points about the sustainability of the structures which they made, and specifically the long-term sustainability. Then an important stats were presented, like 80% of natural coral reef in Polhene area is destroyed. So that's a very interesting stat, I believe. Moving on, we had the second presentation from Lakshan, who was joining from University of Peradeniya, and he talked about extracting phosphorus from the sewage sludge using 5 methods. He discussed about 5 methods, and probably a good research point or further research point for the fertilizer problem in the country. We are talking about nitrogen, phosphorus, and calcium for NPK for agricultural products, and nowadays we are in a kind of crisis to these supply the fertilizers. So would be a good research lead to find a solution for the fertilizer problem. Lastly, we talk about the optimization of coagulation and flocculation process in water. As we all know that alum, we use alum for water treatment in Sri Lanka, but probably it would have some disadvantages, Ganeshika presented the importance of using ferric chloride and ferric sulfate to treat the water. Again, discussion points are there because I'm not too sure whether we are looking at heavy metals in the drinking water. So these are important discussion points for today, and the forum is open for you. Please raise your clarification, and we'll have a fruitful discussion so that the conclusions of this session would take to another stage of research. Please, our presenters are there, and Lakshan is joining from Peradina, so you can raise your clarification and discussion points. Need not to be questions, because this is a good platform to talk and discuss your ideas to research work as well. Well, I have a small question to Ganeshika probably. Now, how did you optimize the usage of ferric chloride and ferric sulfate? Like when you talk about optimization, it's a vast area. Now, is it a mathematical optimization which you have carried out, or is it experimentally you trial some experiments and you try to reach the optimum level? Okay, so it's basically experimental work. Now, what about the, I'm sorry, I'm not an expert in this particular area, but what about the water quality with respect to the heavy metals in Sri Lanka? How do you see ferric sulfate, ferric chloride into the action? Because I again do not have an idea about the alum to heavy metals and so on. So what do you think about these things?
I didn't get.
Now, we have heavy metals. We believe we have heavy metals in water, because as is correctly said, we use surface water to treat and to get the drinking purposes. We believe that we might have heavy metals in that water. Are we treating them, or if so, you are trying to replace alum into ferric chloride and ferric sulfate? Do you see any correlation, or do you see any relationship to the heavy metals removal? That's an open question even for the forum as well, because this is a critical issue, as I understood.
In Sri Lankan context, we don't have ability to treat heavy metals.
Yeah.
Because of the CKDU, I know in and out of this, and we are going for a brackish water reverse osmosis plant to purify the cadmium and arsenic.
Yeah.
That's all.
So this is really kind of an issue to the country. So that could, yeah, Nadi, Dr. Nadika. Yeah, definitely.
Heavy metal concentrations are there. So actually that's very practical question, like whether when it is going to, I think in year one that substitution, yeah, obviously good, but you may come up with the water quality measurements in the in terms of at least key heavy metal concentrations. Then only you can come up with the fine-tuning your outcomes, like even in terms of alum, then we may improve it adding coagulant aid, isn't it? Like maybe a polymer, which may give better outcome, and like 50 to 50 instead, like 20 to 80, 30 to 70, right? There are different combinations. I think, I'm sure that this is a start. You may continue with further experiments, right? So, that's the point to think.
when we are applying alum also, it will be leading for asthma.
Yeah.
That also there.
Yeah, definitely. The recent health reports also suggest we have some issues. Even though we don't want to showcase probably, we have some issues in water qualities in Sri Lanka. So a very good research lead for you to carry out and in the future. Yeah, any other discussion points for the other presenters as well? Okay, quick lead on Samadika. So, how do you see the long-term sustainability of your product? Now, we have several questions about the shape of the structures, and as well as the porosity, and also on top of that, I have a slight addition to that one. Now, when you talk about the natural or the traditional concrete, we have reinforcement in it. What is the impact of your fine aggregates to the reinforcement in terms of corrosion and so on? Because you are talking about the marine environment, which we naturally have corrosion to the reinforcement, and probably the structures might not long last. So, do you have any idea about these points?
Previously, in a literature review, I have a lot of research for the tile waste used in the concrete, but I can't find any. They are not using some product. They every research are doing for the strength and like this. That's why that's another gap I find.
Okay.
That's why using that type of because for the coral they need to the high strength, and then the materials we use for the normal concrete for that type of product. We can use that type of waste, and the another thing is the ceramic waste is very durable, at least 500 years. That's why I using that material. And second question is sustainability. That's a just start. We'll try to develop measurement other parameters previously talk about, and we design try to design different design module. It's like a different environment and geographical area.
Yeah. I understand. Now, when did you actually start the experiments?
2019.
So you have kind of 3 years.
Yeah.
Do you see any progression? Okay, I've seen your videos and so on. It captures the coral, the aquatic, or the marine creatures to them. But apart from that, have you seen any engineering perspective of the long-term sustainability of those things? I know it is just 3 years, but
issues was in the natural environment. I go to the last week. A sample, covered by the sand.
That's another important point.
Yeah.
See?
Definitely we need to the different location and different structures. That's why we we search for some grants and develop other area. I think we try to develop different shapes and different location. That's we can get an idea what are the good design and what are the shapes, because we can only also use it true location.
Right.
With we have this is a cost, very cost. We try to develop different modules and different location, and I think we can finally get an idea what are the best shapes and material composition likewise in the future.
Any research discussions
and we try to in the reinforcement currently we are using the metal, but we try to using the bamboo and other natural reinforcement for the concrete.
So what's your argument? Because it's very clearly saying you are trying to go for the conservation of corals, right?
Yeah.
So that's the material is, yes, I understand ceramic tile from the waste as fine aggregate. So still like number one, heavy metals. And not only that, because these are like mercury, like when the fish eat, when we eat fish, that impact is not very quick. So it takes years to come up with.
We are search for the, if there is a XRD, we can find any lead or like heavy metal in that waste. We are only using waste material and other same are the cement and sand, cement and coke.
And the
fish are banned because of the inside the flesh of the fish there are plastic particles.
Microplastic.
Microplastics, and it affect to the cancers of the body. And so you said you mix the concrete with the bamboo. So then I wonder if the density of that material is reduced, then the material deep in the water will float. No, I mean the concrete. So nowadays we have the lightweight brick produced by some company, and that can float on the surface of the water because the density is 800. Normally the water density is 1000. No, and the concrete material which should dip inside the sea should be more than 1000. So if we mix it, sometimes it will be affected to the density, and we have to consider the ratio of mixing.
Very important discussion. Like to have a long-lasting sustainability of these products, you probably have to think about the water quality aspects and durability of these materials and the structures, and not only that, probably the sediment budget, as you correctly said. So Sri Lanka is an island, so we have to clearly think about the sediment budget. And one last research thing, like now Pollehena is very famous for tourists to have a go there. Now you said 80% of coral
damaged.
Structures are damaged. So are we seeing that Pollehena is no longer suitable for natural baths and swimming and activities? Because that can impact the waves. Definitely the coral layer brings the breaking point of the waves far from the
90% are reduced the coral. In the Pollehena area, that's a previous video. You can see the weekend the currently they are reduce the tourists for the going to the sea. In that design, we try to not a ban for the tourists. We try to the guide for they can one module they can this is like a paving. The tourists can walk to the bigger module, and they can safely go around the sea area without damaging the natural reef. That's the idea we try to that's location, and with the location we can do in the different structures.
Lakshan, we haven't forgotten you.
Can I ask a question from Mr. Liyanage?
Yeah, sure. Go ahead. This is a discussion point.
So Mr. Liyanage, in your building of those concrete blocks, so I am a little bit interested how much ceramic waste can you put into the concrete mixture? That means is it like 20%, 10% or 50%? Some.
You asked for the chemical I will use the only sand replacement. In my research, I will use 25, 50 and 75 in the sand replacement.
Okay. Thank you very much.
75, 25, 50 and 75 and 100. I use sand. Yeah.
25%.
50, 75 and 100. Sand. Cement and chorus are fixed. I only variable part is sand.
So that's what I asked was what is the ratio that you mix porcelain dust to cement?
That's a previously I mix 1:4 mix ratio using and 2 in the sand. I previously said 25, 50 and 75 and 100. But and cement and chorus aggregate are fixed, and we can use as a tile particle. There's another research. We can use tile particle for the chorus aggregate.
Okay, thank you very much.
Thank you.
Okay, any questions or discussion points to Lakshan? He presented something related to phosphorus-based products from sludge. So that could lead a new research idea to probably replace the fertilizer import. We import a lot of fertilizer to the country. Probably extensive research would be needed to have a finalized or final product. But this is just a starting point. Any discussion points to Lakshan? Okay, Lakshan, how do you see the economic feasibility of this one? Just to start.
Yes, sir, in the literature survey, so we calculated the not the installation costs but the operational costs of these methods. So that was also another point in the shortlist procedure where we had about 10 to 12 methods, and we did the shortlisting for the to reduce the list to 5 methods, and these the 5 methods we have selected are actually already in use. They are not still in like experimental stages. So there are a lot of methods that are still in development stages. So when those methods come in, the cost will be further reduced. So I feel like that Sri Lanka needs something like this, because even our country also depend on rock phosphate reservoir. So when the things run out, we will be in a dire situation.
Okay. Yep. Please go ahead.
This goes to Mr. Liyanage.
All right.
Then what is the best proportion of the, you told that the partial replacement of sand, you collected some tiles material. Okay. Then what is the best proportion of the, you got?
The strength is 25%.
Yeah. Then you got the maximum strength of 25. Okay. Then as I will suggest that you can, in behalf of that model, you can use this as to avoid erosion.
Yeah.
You can use that material as the avoiding material of the erosion. Most of the cases, the last few days also, the sea or erosion is occur some places of southern province. Yeah. So you can easily use that one for this for the avoiding erosion purposes. Yeah. Another thing, if you add like this type of things as a replacement of coral product or something, then someday it will destroy our natural diversity. Okay? Then I think you think about that also. You told that it will provide like a pathway for the foreigners also. But why did you use such a pathway?
In the Polhen area, we say the coral, a lot of coral are damaged for the tourists. They don't concern about the coral. They and other activities in the Polhen beach, turtle watching. They came to the visit looking for turtle. They don't concern about the coral. The coral is a very small pieces. That's why we need to not only ban to the tourists. We can engage the guests, and we provide the safe path for them, and protect the other corals.
But this is not the natural thing, no? So it will get some problems in the future.
We need to simulate. Yeah, definitely.
Yeah, I think you know, as we discussed, the long-term sustainability is still a question. So probably we need a lot of research on these areas. When we try to find alternatives to the natural stuff, we always have to be concerned about these things. Now, we have almost come to the end of this session. I'm sure you have a lot of other questions, clarifications to go with the presenters today. And however, you know, everything you know has an end. But the good thing is, even though we had only 3 presentations for this technical session, I do believe that we have at least new 10 research topics from these 3. So we realize that what we have to do as the next steps. And from the wonderful 3 presenters, we learn a lot, as well as the discussion with you helped even me to understand a lot of things, because I'm not an expert in all these 3 areas. So I learned a lot, and I should definitely thank you to enlighten me in these things. Now, just for the concluding remarks, we had 3 presentations from Mr. Liyanage and Mr. Lakshan and Ms. Ganeshika. So they were talking about some important aspects of the ecosystem and their solutions. These solutions might not be the perfect, but these are the starting points of the identifying sustainable solutions for future generations, probably. So keeping that in mind, let us move to the next session, probably. And I should thank Latika for helping me to keep the time, because we are supposed to end this at 2:40, and we are right on money, I think. So thanks, Latika, and thank you for the kind and flattered introduction about me. And finally, thanks goes to 3 presenters and the podium and the floor as well. So thank you very much.
Thank you, sir. Now, I would like to invite the session chair, Professor Upaka Rathnayake, to award certificates to the presenters, assisted by Head of Department of Civil Engineering, Dr. Thanuja Kulatunga. Mr. S. U. Liyanage. Ms. P.G. in Nilmalgoda. Thank you, sir and madam. And I would like to kindly request you to remain on stage, please. Next, in appreciation of Professor Rathnayaka's valuable time and efforts in making this session a success, I would like to invite Dean Faculty of Engineering, retired Captain my apologies. I would like to invite Rector, City Campus, Major General Lal Gunasekara, to present Professor Upaka Rathnayake with a token of appreciation, assisted by Head of Department of Civil Engineering, Dr. Tanuja Kulatunga. Thank you, sir and madam. I would like to take a moment of your time, please. As seen in this slide, the Faculty of Engineering of KDU has launched its very own journal, the Journal of Advances in Engineering. Submission of manuscripts for Volume 1, Issue 2 of JOAE are now open, and I would like to kindly invite you to submit your manuscripts before the deadline, 31st October 2022. Ladies and gentlemen, now we have reached the end of the civil engineering session of the Kottalawa Defence University International Research Conference of 2022. I would like to thank the presenters and everyone gathered here today for the completion of a successful and informative session. Marking the end of today's program, I would like to invite you all to join us for some refreshments outside the hall. Thank you and have a good day.